This is a tutorial on how to develop the tic-tac-toe example that was discussed in lecture. I have here the Spyder development environment, which has a couple of main windows that I'll be using in this tutorial. On the left-hand side, I have a script window, which lets me write a new Python script and save it for later execution. Over on the right-hand side at the top are a couple of tabs to help with the development process. I can inspect objects to read the help manual instructions. I can inspect variables which have been defined in the console window, and I can also explore files associated with the scripts that are being run. In the bottom right-hand corner is the Python console, where I can type in directly Python instructions and see the output of those instructions. Now in the tic-tac-toe model, what we're mostly interested to do is represent the model state. The model state is the set of information that describes a tic-tac-toe game. Now if you remember, a tic-tac-toe game looks a little bit like this. There's a space for up to 3 characters, either X or O, in 3 lines. Now what we want to do is actually represent this model state with a 2-dimensional array or matrix of strings. So these X and O characters are actually they're called strings. They're text, and it's just a single character's worth. So in Python, the easiest way to do this is to just start typing. I'm going to save this file as example tic-tac-toe, and just try testing out a couple of ideas. So I'm going to define in my script over on the left-hand side a new variable called state, and I want to first assign this state variable to a list of characters. And I'm just going to try to recreate the same structure that I have up here, starting with the first row. Need an X, O, and X. Now in Python, the syntax for writing a list is that you need to have the square brackets on the left and right hand side of the list, and each of the list items separated with a comma. In this case, the list items are all strings. Strings are represented as text that's in between either double quotation marks or single quotation marks. Both of those options work in Python. Now, this is not a complete model state. It's only representing the first row. But I can try running this to see if it is registering properly in the console. So I'm going to save my script file and then click the green arrow to run it. Now when I run the script, it actually runs in this console down here in the lower right hand side. I can see that it's run this file, but I don't see any actual outputs. That's partially because I don't have any print statements in my script. However, I can investigate some of the variables that are available by looking at the Variable Explorer tab in the upper right-hand side. Here I see that there's one variable named state. It's a list. It has 3 elements, and the value of those elements are X, O, and X. And I can double-check this variable by simply entering it into the console state and see the output, which returns the value of this state, X, O, X. So that looks good so far. The challenge, though, is how do we recreate the 3 rows of 3 columns in Python? I'm just going to switch these over to double quotation marks for consistency. So the easiest way to do this is actually to make the realization that all a 2-dimensional array or matrix is just a list of lists or an array of arrays. What we can do is create a second set of square brackets to enclose this first and simply have it interpret this first set of brackets as the first row. So I'm going to copy and paste the same first row separated by commas again as to be the second and third rows of the state variable. So now I have a list which has 3 elements. Here's the first element, second element, third element. Each of the elements is a list itself, and inside of those lists are 3 strings, x, o, and x. So let's try running this example. You can see my variable explorer over here in the upper right hand corner. I now see that the state variable is still a list, size 3, but its values are now these 3 rows. I can similarly print this out to the screen in the console. Now, one of the challenges is that this doesn't really look graphically like a tic-tac-toe board. It still looks kind of like 3 lists that are just appended together. So what we can do instead is to create a print statement to print this state in a more, I guess, a nicer form to display on the screen. So in Python, you can write print statements using the keyword print followed by the variable that you want to display. So if I printed the state itself over here in the script, run it, I get the same display of the 3 rows all appended together in one line. However, if I want to only print one of the rows at once, I can index the row that I want, or the list element that I want, with a set of square brackets and the number of that index. Now in Python, like many other programming languages, these list indices always start with the number 0. So 0 is the first row, 1 is the second, 2 is the third, and so on. So if I print only the 0th entry in the state matrix, I'll just get this first line, XOX. Similarly, if I want to print the other 2 lines on successive rows, I can print state index 1 and state index 2. If I run this script, I can see over here on the right-hand side that I get these 3 rows. Now this works perfectly fine, but in Python there's many other ways that you can get the same behavior out of a script in a more, I guess, a more flexible notation. One way of doing this is by using what are called iterators to iterate over different variables. We can see here that we're going from row 0 to row 1 to row 2. We can actually use, you can iterate over all of the possible rows to do this much more easily. So the iterators in Python look a little bit like this. They start with, one way of doing this is by wrapping it in a for statement. So if we want to loop over all of the rows, or we want to loop over each of the rows in the state variable, we can use a for statement, and then simply print the row to console. So by running this command, we're looking at the state, and we know the state has 3 elements in it, 0, 1, and 2. This bit of code is taking each of those sequentially, assigning them to this temporary variable row, and then printing that variable to the console. We can see we get the same result as we did from the simple method of printing the state. So since these 2 are the same, I'm just going to delete this first sample that we were working with. Make sure that we still get the same output, the same expected output, these 3 rows. Now this row variable is just a temporary variable. We could really call it whatever we want. For example, we could call it I. So for each of the elements in the state variable, we're assigning that to a temporary variable I, and printing that I to console, which again are these 3 rows. But it's better to be a little bit more, clear what you're actually doing in your code, which is why I'll typically use descriptive words like row. Now, the other improvement we could make is possibly separating each of these rather than printing the actual list itself, but by printing the characters separated by a vertical bar or a vertical bar. So Python makes it very easy to separate code or to format strings from lists. If we want to separate each of these columns by a vertical bar, we can print that vertical bar and join it to all of those row elements. So this notation takes each of the elements in row, which you can each are the cells of the tic-tac-toe game, and joins them using a bar between them, a vertical brace. So if we run this little bit of code, we can see our new formatted outputs are simply the characters themselves, not the entire list, and they're separated with a vertical bar between them. Now, the only other thing that's missing from this display is the horizontal lines that separate these three columns. Now, an easy way to do that with our current program is simply to print some horizontal lines after each of the rows is being printed out to the screen. So this will print the first row and then these 6 horizontal bars, and then the second row followed by the second set of horizontal lines, and then finally the third row followed by these set of horizontal lines. Now, the only challenge with this is that, well, we don't really need this last row down here. So what we can do is add in a check to see whether the current row that we're looking at in this code is the last row, or whether it's not the last row, because we don't need this last line under the last row. So for this bit of logic, we'll use an if statement. So an if statement is looking to see if a certain condition is true or false. And what I'm going to check to see is if the row that I'm currently looking at is the last row in the state variable. Now, similar to before, how we were indexing the list elements in the state variable with an integer or an index, we can use the special index -1 to see if it's the last or the final element in the state list. So I'm going to put in a colon here, which is the end of the if statement, and then indent this print statement to say that this print statement is only going to happen if this if statement resolves to true. Now, I've made a slight mistake here, where if I try to run this code as it is, we can see that the output only gives us the exact line that we wanted to try to remove, this last row. And the reason is that the logic that we wrote was if the row is the last state element, if it's the last row, then print the horizontal line. However, what we really wanted to check is if it's not the last state element. So rather than using just the is keyword, we'll use the combination is not that does the combination check. And we get the corresponding nicely formatted output from this very simple model state. Now, so far, we've just been developing, I'd say, free form in the Python script. We've been using what are called global variables, or globally defined variables. These are variables that we've just used in the script and that we run and we can access directly from the console. So, for example, I can type in state here. I can see the output from that state variable, as we were seeing before. When we're developing a sense of a model, though, we want to assign these state variables and other functionality to some sort of a model object or a model concept. And in Python, this is done by creating what are called class definitions. Now, in this example, and in the tic-tac-toe example in general, what we're trying to do is develop a model state for a tic-tac-toe game. that game is the central model or object that we're trying to define. So in Python, how we're going to represent that idea is by defining what's called a class. A class is simply an object which can have state variables and functions associated with it. In this case, I'm going to create a class Tic-Tac-Toe game. And inside of this class, I'm going to assign a special function called an initializer, which will be always called the first time an object of this type is created. And in Python, this initializer function has a very special signature or syntax. You use the keyword def, which means you're defining a new function. And this function name is __init __. This is short for initialize. Then we need a left and right parenthesis, and inside of those parentheses, we need to use a special variable called self. Now, self is the actual tic-tac-toe game that is being initialized, and we can use it in the initializer to set some of the model properties or the model state variables associated with one particular game. And in this case, all we're going to do is copy in this existing state variable. So I'm just deleting a couple of lines here. So we now have the state as being a part of this initialization function. It's inside of the function body. And rather than using a global variable here, I'm going to assign it to the self object. So self.state means that the state variable, it becomes a member property of the object that's being initialized. So just to wrap things up here with the rest of our script, I'm also going to move this print statement inside of a separate function. I'm going to define another function for the tic-tac-toe game to print the state. And again, I'm going to use the self argument to identify which tic-tac-toe game are we actually trying to print the state for. Now, since I want to move this code inside of this function, I'm going to indent it by a couple of tabs so that it's inside of this function definition block. In Python, all of the code inside of a function has to be indented at the same level. And now we have to also specify which variable state do we want to print. In this case, it's its own self state. So self.state means the state variable associated with the particular tic-tac-toe game that is being used for this function. And I'll have to also update this other state reference down here, self.state. Okay. So we've moved our code for our state variable inside of the initializer function. We've moved the code to print the state to console inside of its own function as well. Let's test this out. I'm going to continue writing some test scripts down here below outside of the tic-tac-toe game class. And in particular, I'm going to write maybe a variable t, and the value of this variable t I'm going to create as a tic-tac-toe game with the left and right parenthesis. What this instruction means is that t is going to become an entire tic-tac-toe game with all of the state variables that we've defined, which in this case is simply this one state variable, and it also provides this functionality to run specific code for this t game. So if I run the script as it is, check over here in the console, I can type t. I can see that what this variable is a tic-tac-toe game instance. This other data over here is the memory address that this object is stored at inside of Python. And I can start to use some of the functionality that I've defined over here. It's already been initialized. That's what these left and right parentheses mean. But I can investigate some of the variables associated with this object. So if I type t.state, I can see the state variable that's for this particular tic-tac-toe game named t. And I can also run that print state function on this object by saying t.print state left in a parenthesis, and it will print out the model state for this particular variable. Now you may be asking, why is this so useful? Well, the answer is because we can now create many different games. So I'll make a second tic-tac-toe game. And these are treated as two separate objects in the Python code. So if I see the state of the first game, t, I can see that it has its initial conditions, and the second game also has the same initial conditions, but I can start to modify these and start to diverge how the model state is represented between these two games of tic-tac-toe. So that's the subject of the next steps of this example. So we've defined the initialization, which assigns the particular state variable. We can print it out to the console, but what we really want is an ability to change the state. So we're going to define a new behavior or a new function that will perform a state change. Now in this case, I'm going to define again a new function. I'm going to define the function as mark. Mark means to change the value of one of the state entries. Now this function definition still requires the self keyword, and that tells it what object or what tic-tac-toe game do we want to perform this function on. But the other information we need to know are, for example, what row to mark, what column, and what symbol do we want to write in this function. A colon to end the definition of this Python function, and now we can start filling in the body. Now the simplest way of thinking about this mark function is simply to update one of those cells in the state variable at the particular row and column that we want to change. That's fairly straightforward to do. We need to access the state variable on its own, on its self object. And we need to index using these bracket notations again, not just the row, but also the column. These can be combined in one step. On Python, it uses row first indexing and then column-based indexing. So this first bracket with the variable row will find the row either 0, 1, or 2 out of the state variable. And the second bracket will either get the column number 0, 1, or 2 out of the state variable. And we can then update the value of that row and column to be whatever the new symbol is. Okay. So I'm going to rerun the script to update the console to let it know that we have this new function available, and let's test it out to see if it actually works. So I still have over here in the console the t variable, and it has the same default model state. But if I try to mark this tic-tac-toe game, maybe row 0, column 0, I can give it some sort of a new character or a new symbol to assign. So this instruction tries to mark row 0, column 0 with the letter A. Now if I investigate the state of this game, we can see that this first row and the first column has been updated with the A symbol, and it's even easier to see if we use the print state function to see that, this row 0, column 0 of the T game has been updated to the symbol A. Meanwhile, the second game, T2, still has the same initial conditions, so it hasn't been modified or changed by this other change to game T. So this is pretty helpful. We're well on our way to completing the tic-tac-toe example. There's just a few things to clean up. in our code. So the first important change is that we had our state initialized to this kind of placeholder data, XOX, XOX, XOX. What we really want to do is just to have blank characters holding the spot of these state variables. So I'm just going to erase all of these existing X's and O's and keep just the simple space. I'm also going to erase this comment that we had before that was helping us understand what we're developing. Okay, so I've updated the state to be just blank to start with, so that looks good. If we run the script again and take a look at the t variable to print state, you can see that we have an empty game board. Very nice. One other thing that we may be interested to is to add a failsafe into this mark function to make sure that we can never override one of the existing symbols if it's already been marked. So the way we could implement that is by using another if check to see if the row and column that we're trying to mark already has a value or whether it's just blank. So just before writing this new symbol at the row and column, I'm going to add in an if check to see if the self state at row and column is a space. So if it's space, if it's blank, then we know that it's okay to overwrite that row and column with a new symbol. The way that we can convey this information back to the user is, in this case, returning the value true, meaning that yes, this was a successful mark and it can help some of the later programming logic. Otherwise, if this if condition is not true, we want to run some other code. Specifically, in the else condition, we can return false. All right, so let's test out this updated mark functionality. I'm just going to get rid of the second tic-tac-toe game, clarity. So if I run the script, I'm going to be working over here in the console window, I can see the initial state from the tic-tac-toe game. It's blank. That's good. Now let's assume that the first player, X, wants to go in cell 1, 1, the center. It's a pretty good option. So I can enter in this instruction, mark row 1, column 1 with an X in game T. That instruction returned true, meaning that it was a successful operation, and if I try to print the state for this game T, I can now see that that X has been marked in the center location. However, if on the next turn, if we try to mark that same game in the same location, 1, 1, with an O, we can now see that the response from that function is false, meaning that it was not successful. There was no changes that were made to the state variables. And if we actually inspect the print state for that game, we can see there's still only one symbol. It's an X. It's in the center of the game. Or it's in the center of the board, meaning that in the game logic, we'd probably want the O player to try to make a choice. So it seems that our game logic is working pretty well. In the first assignment, you have a couple of other tasks. I ask you to fill in another function called getWinner. So in this function, which I'm just going to leave as pass right now, you'll have to investigate the state to check to see if there is a winning condition. Is there any symbol that has 3 marks in a row in any row, column, or diagonal? If so, you'll have to return true. Otherwise, the default answer for this getWinner function should be special value none. The second function that you'll have to enter, or you have to fill in, is a check to see if there is a tie. I'll also leave this just as a blank function for now, just using the word pass to skip the operations. But this function will also have to investigate the state to see if there's a tie condition And a tie is defined as being no possible winners for the game. There's a couple of ways you can go about checking the state for that condition, and I'll leave it up to you whether or how to actually implement that. The other thing we can do to clean up this example a little bit more is to move all of our testing code into what's called the main function, or the main execution. In Python, usually at the bottom of the file, after any of the class definitions are made, we use a special little bit of code to check if a special variable called __name __ is set to a value __main __. Now, this little bit of code only will evaluate to true if the program that's being run, if the script that's being run has this code in it. So this helps in larger projects by assigning some test code inside of a script you're developing, but that code here will not be run if you choose to use this script or this file in some other program. Now, for most of the cases in this class, this is only good practice. It's not required, but it's something that I'll try to do in my examples to keep the code looking good. So just to finish up this example, I'm going to write a couple of more test instructions to make sure that we've programmed everything correctly. So I have this first game, Tic-Tac-Toe game. I want to mark at position 1, 1, and X, and then print that state to the console. So now when I run the script, I can see that this code is being picked up because it's being run as the main file. I can see that we have this updated state with the 1x in the middle. I can try marking spot 1, 1 with an O, and then print the state. So this is the same test we tried before, where this instruction actually failed. So there's a return value of false that was supplied by the mark function. We aren't returning that. We aren't using that returned value at all. But we can see that the updated game is the same as before. So we can simply try to mark another location. So for example, 0, 2 with an O, and update and print out that updated state. And we can see in this third iteration of the model, we get the appropriate behavior. So when you're developing these getWinner and isTie methods, it may be helpful to update the state for a known condition to check to see whether those functions are correct or not. So just as an example, we can fill out the rest of this game either by adding in more mark instructions, so maybe to mark the next X location at 1, 0. Or what may actually be easier is just to override the entire state for this game to directly access that state and assign it to be some new value, such as maybe X, X, X in the first row, and some other set of values elsewhere. So in this particular game, which I don't think it's possible to get to unless, I guess if O starts first, then this is a possible ending state of the game. This particular model state does have a winner. It's the X player, because they've collected three in a row in the top row. So that would be an example of something to check for in the getWinner function. I'll leave this recording now, and please feel free to post questions about your experience.